Today, I am going to explain working principle of relay. I hope you have used this relay in first semester FEEE lab. This is a DC 5 volts relay. I'll show you another one. This is also 5 volts DC relay. So here it is written 7 amps. Here it is written 7 amps, 240 volts AC. So the meaning of this is the relay can handle, this relay can handle maximum current of 7 amps at an AC voltage of 240 volts. This is the meaning. So it can handle maximum current of 7 amps at AC voltage of 240 volts. So this is the maximum load it can switch for AC appliances. AC appliances like fans, lights, etc. So here it is also written 7 amps, 14 volts DC. So the relay can also handle maximum current of 7 amps at DC voltage of 14 volts. So this becomes the maximum load it can switch for DC powered devices. For example, motors or LED strips, etc. Okay, this is the meaning of 7 volts, 240 volts AC, 7 amps, 7 amps, 240 volts AC, 7 amps, 14 volts DC. And below this, it is written JQC3F something CS DC 5 volts. So the meaning of this is the relay, this is the relay model number. So it is identifying its type, design specifications. So DC 5 volts means the coil voltage of a relay. It requires 5 volts DC to activate. For the activation of this relay, it requires 5 volts. If it is written 12 volts, then the coil voltage of relay requires 12 volts DC to activate or switch. So that is the meaning. So the relay can control both AC load as well as DC load. That's why it is written DC and AC here with maximum currents and voltage specified on the relay. So it requires 5 volts DC signal to operate its internal switching mechanism. That is the meaning. Okay, next. This is the top view. This is the bottom view. You can see here 2 pins on this side and 3 pins on this side. This becomes the primary side of the coil the relay, and this is the secondary side. And this is called as single pole double throw relay. So the relay what I have shown is single pole double throw relay. It is most commonly used in lab, and it is 5-pin relay. 5 pin. These are the 5 pins. 3 pins on one side and 2 pins on other side. This is 5 pins. The 2 pins are the coil. Coil here. This pin and this pin are the coil pins. And the middle one is, this middle one is common pin. And other side 2 pins, normally open and normally close pins. The common pin is always used. And you can use both normally close and normally open. And it's common to use just one of them. So you cannot use both at a time. You can use only one. So what is normally open? I'll explain you now. This is normally open connection. Okay. So if you want the device, what is the device you have connected? Lamp. So through AC supply, you have connected to normally open. And initially the common is to normally close. Switch is open here. On the coil side, you have connected one switch and DC supply. How much DC supply I should apply for 5 volts relay? I should apply 5 volts DC supply between these two coil through a switch. And on the other side, normally open and normally close, I am connecting lamp to normally open. Okay. So if you want your bulb, AC lamp, to switch on or to switch off and to be disconnected from the power supply. Initially, if you want it to be disconnected from the power supply when relay is not activated, then you should connect to normally open. If you don't want your lamp to be connected initially to the power, then you connect AC lamp to normally open. Okay, remember, if you don't want your device to be connected to the AC supply initially, then you connect your device to normally open. As soon as you close the switch, then the power is supplied to the primary coil. So as soon as the relay coil receives the power, the switch when the switch closes, it completes the circuit and it allows the electricity to flow through it, so that when the electricity flows through the primary coil, the common terminal which was connected to the normally closed, it gets connected to normally open. So when common is connected to normally open, power supply is connected to lamp, the lamp is turned on. So when you open the switch, then the common terminal which was connected to normally open, it gets connected to normally close. AC supply is disconnected and AC lamp will be turned off. So this is the meaning of normally open connection, open pin connection. Now I'll show you normally closed connection. So in normally closed connection, if you want your device to be initially switched on, if you want your device to be connected initial to the power supply, then connect your device to normally close. This is the meaning. When relay is not activated, then even though when the relay is not activated, you want your device to be on, then connect it to normally close. Okay, that is the meaning. Then when as soon as the switch is turned on, switch is connected, then DC supply is applied to the coil. So as soon as the coil receives the power, it causes the switch to common terminal gets connected to normally open. So when it is connected to normally open, AC supply is disconnected to the lamp becomes off. So when coil is activated, when relay is activated, lamp becomes off. When relay is not activated, lamp will be in on condition. In above case, when relay is not activated, lamp is in off condition. When relay is activated, lamp becomes on condition. That is the meaning of normally closed switch connection. So inside the coil, you have these pins: normally closed, normally open, coil, and a common terminal. So this is the image of 5 volt pin relay. So in this way, you can use this relay to switch to turn on your devices which are connected to the normally open and normally closed pins. This is the working principle of relay.